Are you want to become an embedded system engineer? After all, the ability to design an entire computer with your own two hands is little nice. We will be revealing everything you need to know about embedded engineering, the technologies they use, the absurd compensation, and the subtle secrets of what makes it so intriguing. Let's discover what it means to be an embedded engineer and give it to you straight. This is the reality of embedded systems engineering. First, we figure out what is embedded engineers. We would like to think of them as gadget sorcerers. These engineers meticulously perfect the engines and bodies of all the seamless gadgets of today, from smart watches to flight control systems on space shuttles. Embedded engineers are behind all of the magic, which is nice, but what is embedded system and how does it work? Basically, an embedded system is a small computer-like mix of technologies that takes analog, digital, or user inputs and applies its internal algorithms to produce an output depending on what inputs are given. Take a surgical arm, for example. The goal of this embedded system is to perfectly mimic a doctor's careful incision as its input and then recreated it on a much smaller and more precise scale as its output. The entire system that senses, processes, and translates the doctor's action to its own is all inside the surgical arm. In other words, the entire system is embedded right into the device. University courseworks. Now let's see the university paths that lead you to your career in embedded systems. There are few, but the most relevant is computer engineering. Make sure to not get demotivated if you are looking into embedded and don't have the right degree. You can become an embedded engineer, or any engineer for that matter, if you are willing to put in the extra work to train yourself. But what works do you have to do to become an embedded engineer? Let's discuss the most imperative college courses to take for aspiring embedded engineers. Now let's start it off with the audience favorite, the embedded system design class. Just like it sounds, this course mimics a real-world embedded design. In the next part of the video, we are covering everything to do with the embedded design process, so sit tight to hear the details for this one. But there's not going to be much sitting and waiting in your embedded degree. You have got microcontroller and microprocessor courses up next. The heart of any embedded design is a microcontroller, or in simple words, microprocessor, which are typically programmed in the C programming language. Here you will gain a ton of insight into controlling peripherals with a microcontroller and the C skills necessary to get it done. If you want to practice this extremely important skills to home, we recommend trying out the beginner-friendly Arduino microcontroller. From simple LED circuits to developing robots in a homemade 3D printers, Arduinos give a great indication of any microcontroller-related field for all skills levels. Next, the computer system and the architecture courses, giving a detailed perspective on all the electronics that go into making a computer. Further, these courses teach you how to interface with peripherals, users, and even other computers. Similarly, it is imperative that you take a low-level programming class so you understand enough machine language to control the hardware in your embedded designs. Later on, most embedded engineers need to know a healthy chunk of circuit as well for hardware design and debugging, which leads us to the shocking world of analog and digital circuits. Topics in these courses include everything from simple passive devices and logic gates to more intricate circuit schemes that really get those oscillators teetering. The last classes we will touch on are extremely important to embedded engineers. Data structure and algorithms. Debatably, the harshest constraints of embedded designs are the time and computing power that your programs consume, that is structure background for efficient practices and structures. Now, of course, there are other important math, physics, and engineering courses that have varying levels of real-world help for your career, but the ones we just covered are pretty much the must-haves for embedded engineering. Embedded engineer salary. Let's move from the university stuff to embedded engineer salary. The niche, tedious and rewarding work that they do. Embedded software and system engineers earns $151K to $170,000 a year on average in United States. Compensation aside, embedded engineering is a growing and fantastically interesting field that perfectly blends the high elegance of software into the discrete atmosphere of hardware electronics. Pros and cons. It's time to tie everything together with pros and cons. On the bright side, talented embedded engineers are valued very highly by peers and companies, and this fact reflected well in their sizable paychecks. This also means that they generally have great job security, as having a deep understanding of the various embedded technologies is a rare skill set. These engineers also sleep well knowing they have the ability to create entire smart computerized systems all on their own. A skill set not many engineers can claim. Continuing, these engineers find themselves in the best in both worlds, not just working software, no only hardware, but being able to switch it up and keep things fresh whenever they want without having to switch companies or careers. And also, embedded engineers have the benefits to going out in the world and experiencing the fruits of their labor. They can sit and enjoy the air control system that they design for commercial airliners, fly around the drones they spent so many hours developing, or watch the robot they took part in designing learn to complete its first front flip. But of course, there's always a downside. It's take a lot engineering skills to flourish in this role. Getting to the point is no easy task, and it takes a specific type of person to work hard enough to long enough. From my perspective, these engineers also experience tight deadlines more regularly than other engineering fields and can end up working long, high-pressure hours of overtime. Although these aspects may or may not be true depending on company cultures and your specific role within the company. Upskill your journey. Remember, start your journey with curiosity and dedication. Refine your skills and nurture your creativity. Take the first step today, and remember, at Let Me Study, we are dedicated to empowering your skills. We have created links for our created courses by Let Me Study in the description box. Thank you for watching. Thanks for joining us on this adventure. And don't forget to hit that like button and subscribe for more simple explanations of complex topics. See you next time.